let me go to slideshow mode. Is it still looking okay? Do you see the slides?
Yes.
Okay, good. So this is the seminar on Sudoswap V2. And I think this is this is my second seminar. The first one was on a seal. So this is on a particular audit, and we have three of us from this team here today. It's myself, Rajeev, we have Lucas and David as well. It would have been fantastic to have Gerard and Shodan join us, but unfortunately they can't join us tonight. So yeah, let's get started. So some of the high-level details, right? This is, first thanks to Hiccup, who shared this template with us. So we didn't have to, do any of that work. And this particular audit, the timeline was 2.5 weeks in Feb. So it was a while ago. And hopefully we will be able to share as much as we remember. And it was a standard 2.5 week and a 2-week fixed review, so nothing different there. And quickly, so this may be a bit different. I've attended a couple of these seminars, and I know that the invitation for this workshop says that we will talk about a few of the key special issues. But I think we are probably going to take a different approach. We are going to go, we think most of the issues are sort of special in their own way. So we will take a breadth approach and try to cover as many issues as possible. So we will not be going, deep into any one particular issue, because I don't think we can do justice to the code base or to the issues themselves. So we will take a look at, as many high severity and medium severity issues that are possible in the next 45 minutes to an hour. And I think the key will be to sort of summarize the takeaways, right? How did we go about the particular issue, finding that issue, what sort of patterns can we recognize, and also we would like to touch a bit upon the process itself, right? The way we discussed with the team, with the protocol team, and amongst ourselves. So that's sort of the context. Let's sort of dive into sort of a review of the protocol itself, right? Very quickly, the assets in this protocol. So Sudoswap is effectively an AMM for NFTs. It allows swapping of NFTs, both the 721 and any of the multi-token formats, the 1155 ones. And it allows one to swap those for ETH or for ERC20 tokens, right? So that is Sudoswap. And the pricing within each of these pairs is governed by different bonding curves. So that's something interesting in this protocol. And Lucas will be diving a bit deeper into the concept of bonding curves as well as how this protocol works with it, right? So let's look at some of the notable features of V2, right? So this was version 2. The version 1, I believe, of Sudoswap was also audited by Spearbit, and I think Gerard and some others were on it a while ago, in 2022. So the V2 adds a specific set of capabilities to this protocol, right? One of the big ones was the support for ERC 1155, not just 721, which is already there, but 1155 as well. The second one was on-chain royalty support, right? So with NFTs, we have royalties, and there is a ERC, 2981, specifically about royalty, but then, different marketplaces have different ways of handling royalty. So all that sort of royalty logic was added to V2. And the third aspect was this concept of property checking. So typically with pools, these are pools that have NFTs and ETH or ERC20s. They introduced this concept of properties where, for somebody to sell an NFT to a pool, the pool could have defined a particular set of properties that that NFT should have, right? And those could be based on the IDs. This particular V2 has a template for the property, but those could be upgraded as well. So some of the simple properties were part of this particular implementation, like a particular range of IDs is what I remember. So that was interesting. Then there was this concept of settings, which effectively is revenue sharing between the LPs of a particular pool and the owners of that NFT project, right? I mean, there are various terminology there: project owners, NFT owners, and so on. And we will let me not go into that sort of explanation now, but there were a couple of issues related to this revenue sharing. So when we talk about that, I think it'll become more clearer how that works. Then the other big change was this concept of partial fills. So V1 essentially was an all or nothing protocol, where if I were trying to buy a whole bunch of NFTs and I execute a transaction, and if some of those are already gone, as in somebody's already bought them, then this would fail. But they want to essentially make that user experience better, so they introduce this concept of partial fills. So if I have a buy order, and if I have a bunch of different NFTs, or a certain number of NFTs for the 1155 kind, then depending on how many are actually available when this particular transaction executes, those would be filled on a best effort basis. So that's really what partial fills are. So there were a bunch of quite a bit of logic related to how partial filling is fulfilled by the protocol, right? And then there were several other sort of minor changes, such as fee accounting. They introduced different way of charging trade fees and protocol fees. Then the router was sort of I would say optimized and in different ways. So these were overall sort of the big ticket changes, right, of V2. And in order to implement all that, they had a few actors, and actors are essentially entities within a protocol, that may have different trust and threat models. So this is, something that, people have different names for these, but the way that, I personally like to think about these are in terms of actors, who act on assets within the protocol, and the way they act is using various actions, right? So you have assets, actors acting on them, and the various ways they interact with it are the various actions. So using that framework, you can actually build your trust model, threat model, the ways that assets flow within the protocol, who is triggering, which actor is triggering any particular action. Do they have the rights to do that? Is that within our trust model, or is it outside our threat model, and so on? So in the context of this protocol, some of the key actors, well, I think this is comprehensive. We have the router, which is where the users interact, and they, have various swap functions that it implements, and this is, very common terminology. And then there is a factory which spins out, different pairs as and when the pools need to be created. Two actors that were introduced in V2 were this concept of the royalty engine, which deals with the royalty flow, and then this concept of settings, right, which is really a contract between the project, the NFT owner, the NFT project itself, right? So let's say Pudgy Penguins, and then the LPs that create the pools, right? So we'll go into different aspects of these depending on the issues that we are discussing. So this was sort of a very brief intro to the V2 of a protocol. And then now I would like to request David to dive into this. So this is a fantastic chart that was prepared. Interactive chart that shows all the interactions between the various actors and actions, like I was just discussing. It was created by Gerard, I think there is a lot. I mean, this shows you different parts, and David will try to do as much justice as possible in the next 5 to 10 minutes. David?
Okay. So, yeah, as Rajeev said, this diagram is an overview of the whole protocol, more or less, with all these high-level aspects. And we can see the asset flow, the protocol fees, any type of fee, and the basic, the more important actors that Rajeev mentioned before. So we have, for example, the pairs. These pairs are created by creating both first an ERC20 or ETH pair, that is an abstract contract, that it gets inherited by a combination of a pair with an NFT. So one of the main features from Sudoswap version 2 is that they included the ERC 1155. So we found a lot of issues regarding asymmetries between ERC 7721 and 1155. So these swaps are the pairs. First of all, communicate, for example, with the property checker. The property checkers, as Rajeev said, checks different properties in case the pair have, because it is not obligatory. But you can, for example, create a Merkle check, that the NFT IDs are inside some range. This is some type of like user defined, like they wanted this as a main feature, that the creators of the pairs can create these properties. Also, after you call the swap NFTs, it calculates all the fees. For example, it calls the bonding curves that returns these fees in, if I'm not wrong, it was for the protocol. Yeah, there are many fees. We have the protocol, the trade fee. Then we have the factory for the settings. All of these pairs have the settings, as Rajeev mentioned, and you can create for the collections, or you can create for the collections that you need to be the owner. That's checked before on the down part, like on the bottom. There are like different types of checks, if it's from manifold, if it's from digital access controls. So they take into account different types of collections, ways of creating, and check the ownership. And if that's right, you can set like settings for the whole collection. Also, if you are the owner of the collection, there is this reclaim pair function that is on the standard settings, that after a certain time you can call and claim, and then claim the ownership again, and it splits the fees. I don't exactly remember how all that stuff works, but kind of like that. Like, it's for splitting the fees, and only the owners of the collections with the settings owner can interact. And what else? We have the router, that it's also one of the main features of the protocol. They created, this is important to say, because when we started the audit, there were 3 routers. Not only 3. One of those were first said that is not gonna be used. And we have the router one that is like the oldest one, with some adaptations like for the new features. And they created this very fast router that in a high level aspect is the same, like it's gonna interact with the pairs in the same way. But yeah, the very fast wasn't test enough. Didn't have test created, but the router one, yeah, it have a lot. And from that, it makes easier the swaps, the interactions, and yeah. I think in a high level aspect, that's everything I can say. Anything that you or Lucas want to say about this diagram? I might forgot. Well, the royalty engine, that's one of the main features.
Yeah, I was about to say that, but yeah I think pretty much everything is covered.
Yeah, just maybe one other highlight. So this, so you see this, I don't know if you can see my cursor. You can, right? Do you see my cursor moving?
The non-reentrant modifier.
Yeah, so Gerard had this, fantastic legend here for non-reentrant, and as you can see, he diligently marked all the ones that were protected with the reentrancy modifiers, and from using this particular aspect here, color coding, and with all these things, he was able to point out that there is a potential cross-contract reentrancy, right? And then we'll hopefully have the time to look at that in some detail. But that is one, and I forget what these. And just to talk about again the process, right? So this is this way of very pictographically looking at the interactions, and Gerard, I believe, spent quite a bit of time on this. And as you read the code, you build this out. So this is fantastic. To visualize the entire protocol, the flows, and the interactions. So definitely helpful for a lot of people, and some people also for various reasons, maybe laziness, or they just prefer to build a mental model, right, of these things. And clearly, mental model, you need to have a working memory that has all these details in it. So which is very tricky, very hard. So building something like this for a protocol, and I think this has been going around on Twitter as well, that if people can actually build something pictographic and maybe with some details as to what these do, then at least for the popular, widely used protocols, it will be good knowledge sharing, right? So I just want to point that out. Anything else, David or Lucas?
Nothing else.
Okay.
Well, we're gonna dive deeper into the concept of the settings for pairs that users could define, especially bonding curves next. Am I right?
Yes. Yeah. So let's jump on. So there are many details, but I don't think like David said, we can get into any one particular. I mean, all these parts. There wasn't one part of this protocol that was very buggy or very special in any way. It had just multiple things, like David said, right? So we had the settings, the royalties, the bonding curves, and this. What else was that? So those, and then there was a concept of whitelisting of the routers itself. So we'll touch upon some of those aspects. So let's jump out to the next one. I think Lucas is going to take us over an overview of the curves.
Lucas. Sure. Thanks. So the concept of settings was a new one implemented in this version of Sudoswap. So users could actually take a template and create their own logic or settings for their pair. Among those settings, one of the most interesting one was the bonding curves. So we thought it would be interesting to talk about that a little bit, especially for junior security researchers, because it's a concept that at first it may be scary because it doesn't sound familiar at all, but it's something that is actually very, very familiar. As Rajeev mentioned, Sudoswap version 2 is actually an AMM, right? So as we know, an AMM controls the price of tokens based on some mathematical formula. Basically, that mathematical formula is a bonding curve, right? So, as you can see in the slide, the bonding curve is a mathematical formula that defines the price of a token depending on its supply. In the case of, for example, the classic constant product formula, it's depending on supply of tokens, so a pair of tokens. In this case, would be the price of the NFTs defined by its supply, and the price is defined on a Ether or a ERC20 that is defined on pair creation, right? So as stated on the slide, bonding curves allow fixed price discovery mechanism, predetermined price discovery mechanism as well, and uncheatable logic. What does that mean? That you will always have a price that is contemplated at some point by the curve, right? There are many types of curves: exponential, linear logic, linear, sigmoid, quadratic, and the constant product one is also a special case of bonding curve. And the shapes of these curves, the formula, the expressions, depend on how you want to incentivize your market, right? So on the next slide, we have a couple of examples, right? Here you can see classic sigmoid, for example. You see that there's a quick increase in price at medium supply, but price is bounded, right? It tends to an asymptote. That means that there is an unreachable value, like, for example, 3, where the price tends towards 2 when the supply tends to infinity. Then I don't know if you can recall limits in calculus, but that is pretty useful to understand these mathematical formulas. Quadratic, for example, there is uncapped price, right? Negative exponential, the price rises quickly on small supplies, and as supply gets larger, it grows slowly towards a fixed price, say an asymptote. And in linear, you just have a fixed price all over, so there is no relation between price and current supply. So we wanted to highlight that because you still can make use of those, small calculus knowledge we got from high school. So that is pretty neat. Allows you to understand logic. In this case, Sudoswap version 2 based their logic mostly on the negative exponential bonding curve and also the constant product bonding curve. Although we're not showing it here because we assume that it's the most known bonding curve, the constant product bonding curve has a vertical asymptote on 0 and a horizontal asymptote on 0 as well. So that means that if supply of token X tends to 0, the price of token Y tends to infinity, and vice versa, right? So I don't think I want to add anything else. So let's dive into findings. Good idea. So in this audit we had a total of 114 findings, which were composed by 9 high findings, 20 medium findings, 29 low findings, 41 informational findings, and 15 gas, right? And these findings are of very, very different nature. Here we're gonna show you an example of each one of them, but since we'll have some time, we'll just later open up the issues and just showcase some of the most interesting ones. But as Rajeev mentioned earlier, without diving into much detail, because that doesn't make justice to the protocol. But there are several, common properties, common profiles that these issues have that can be highlighted. So let's jump into an example of a high finding. Example, a change spot price at delta, which is a function that estimates parameter, only uses the ERC721 version of balance of, right? You can see there pair.nft.balanceof pair address, right? What happens if the pair is actually an ERC1155? Well, you're missing an argument there. You have to provide the NFT ID. So what does it mean? That during the design or during the implementation of ERC1155 support, their developers didn't take into account the differences among these two ERCs. If you're implementing logic that contemplates two different standards, you better make sure that you completely cover the second standard you're implementing. In this case, that implies adding the ID argument, right? So most of the times, if you got a logic flow working for one standard, it should look pretty similar for the other one, right? So you have to make sure you have both flows working together. In this case, both ERC 721 and ERC 1155. Yeah, that's one example. Next, let's watch a medium one. This one was pretty fun. This is the auth allowed for token function returns prematurely in certain scenarios, causing an authentication denial of service. So what happens here? This is basically a big function that checks out the addresses, and it starts checking out if it's for example, a Nifty registry contract, a foundation treasury contract, a DigitalX access control address. It checks for different marketplaces, right? But it so happens that for the Nifty and the foundation ones, it directly returns the Boolean value without checking if it's true or false. Because if it was false, you should continue roles from other marketplaces, right? So imagine you had a Nifty address, but it returns false, but it would return true in DigitalX, right? So you're expecting to get an auth allowed for token as true because it would yield true on the DigitalX check, but it actually gives you false because on the Nifty one, it directly returns the Boolean, which will be false, right? So that is not actually true. If you can notice for DigitalX or for art blocks and in the other checks, you actually check the output and you only return it if it's true. So you can, at those points, it can actually return prematurely, and it shows that address doesn't have authentication when they actually do, right? So that was a fun one. And this slow one is pretty simple, but still exists. So there were functions that didn't need actually to have a payable specifier because they didn't make use of ETH. Nevertheless, there was the specifier, and there was no other function within that contract that allowed to rescue Ether. So yeah, you're basically allowing someone to send ETH to this through this function and lose it forever. And as Christophe Michel once said, we cannot protect always users from themselves. True, but make it safe just in case. Make it foolproof, right? Remove the payable specifier so nobody sends Ether on a mistake, right? On a fat finger mistake. Yeah. So this pretty simple one, pretty fun one. It was nice catch. Yeah, we also wanted to talk about gas optimizations. There's always something possible. In this case, really simple one was present. As you know, how structs pack variables in storage, you can optimize that. For example, put the booleans together. They will both together will occupy one word, and yeah, that will make you one storage slot less and will cost less gas, right? So it's just a matter of ordering. It will work well and will not make any impact when accessing fields of the struct. So yeah, it's a better design choice. Quick, easy, nice gas optimization. Yeah. So these are like 4 examples we had, but now we'll dive into the different findings, different issues we had. Rajeev, do you think it's better to read out the general conclusions and then dive into the repo, or should we dive first and read conclusions?
I think we have. Are these seminars meant to be 45 minutes, or we have like 30 more minutes? So let's go over some of the issues if possible, and then come to the summary. Yeah?
Sure. So
Okay.
you want to take the lead here? Or?
Yeah.
Okay.
So, do you see the GitHub that I'm sharing? Do you see this tab? I'm never sure what Discord sharing, how that works. Do you see it?
Yes, see properly.
Okay, good. So we just sorted this out into the high severity ones and the medium severity. So we'll just do like a flyby of as many as possible and try to summarize some of the key takeaways, right? So this one, partial fills, like I mentioned earlier, was one of the things that were added. And similar to the high severity issue that Lucas just explained, there were flows for partial fills specifically for the 1155 swaps, right? And those would fail when the pool has insufficient balance. So I'll just scroll over this, and this may also be interesting to highlight some of the sort of the process aspects, right? Like the way that Spearbit reviews are different from some of the other, other reviews that you may have seen. Is we discuss actively with the project. So I'm guessing that most of you on the call have done some of these audits. But if you haven't, then that's sort of a good thing to notice. So this repo is is the one that Spearbit creates for every audit. There's a separate one, and the issues are created, and the protocol team also has access to these issues. So at many times they are either debating or fixing and sort of challenging on some of the assumptions made in these issues, right? Once these are written out. So in this particular one, again to go back, so the ERC 721 swap, right? So the flow for that was handling the scenario where the pair balance was less than the items that the user requested to be filled, but the similar thing for 1155 swaps was missing the check, right? So that is one takeaway. So obviously both types of NFTs should have very similar very similar flows in which they handle the fills and any errors as well. So obvious recommendation, but one thing I would like to call out is, so this is something we saw was, fixed after the review started, right? So this is, an interesting aspect where the protocol team was also, continued to develop the protocol. I mean, they were adding code, they were changing code while the audit was going on, right? So in some cases, we did keep an eye on their private repo as well. So they were adding PRs to it. Some of them were optimizations, some of them were bug fixes. Obviously, the commit hash for the audit was fixed, right? But if the dev is happening in parallel, and sometimes they were looking at our issues and some of the early issues, and they were actually committing PRs for fixes as well at the same time. So it was happening in parallel, and there are pros and cons of that. So we'll talk a bit about that. But this is definitely possible, right? I mean, this was one of the audits where we saw this. So you'll see things like this in the report that, hey, this was already fixed after the review started, and we had to sort of identify the PR where they made the fix and do the fix review while we are actually doing the audit itself. So it is not a very nice sequential, we do the audit and submit the issues and then they come, right? So things are happening in parallel. So just want to call that out. And David and Lucas, feel free to chime in if I misspeak or if I miss some details that are interesting. So this was, sorry?
So I wanted to comment that also there's this constant conversation going on, right, on the comments of the issues. Yeah. So there is it's not like see, for example, okay, this is a short one, but exactly acknowledged, addressed, and so on, right? There are some issues where the devs even commented, see, we're trying to fix this some time ago. Okay, well, we have a PR that was about this, but yeah, we're gonna put some focus on it right now, and so on, right? It's very dynamic. It's very nice.
Right. So I think there are many, several issues like that. So I'll hopefully scroll and showcase that as well. So this particular issue is pretty interesting. I mean, this was like, Gerard would have really loved for us to dive deeper into this one issue, if nothing else. But this was essentially one of, well, to summarize, this again happened when they added the ERC 1155 support, and they had this token function, which essentially made some assumptions about the particular NFT, underlying NFT's data structure. And because of that, it was reading data about the token from a different offset, right? So this was all written in assembly. So, good point, maybe a finger at why writing assembly code is dangerous or should be really well tested. So that was, that obviously didn't work when the support for 1155 was added. And in this case, again, after the review was started, so this function was updated by the protocol team to actually fix the offset from where they were reading it, right? So this was in a particular PR, and this is something, and the reason why we included, this particular issue in the report, although we did not find it, is one, for completeness, right? Because this happened after the review started. It wasn't in the commit hash that was in scope for the audit, right? And two, even though the protocol team may think that they have fixed it and they have a PR, right, which is happening in parallel, it is really up to the auditing team, right, to review the fix itself. So as part of this, solved, so this is the comment that you see, and that is also the reason why it's included in this report. So let me sort of go a little faster. So this is again sort of switched order of update, and this is pretty common when you have multiple variables that are being updated. So in this case, this was like a binary search, I think. Binary search, and the start was updated before it was used instead of after, instead of updating it after it is being used, right? So this clearly is probably hard. It depends on the test case, but could have been missed out. It would lead to some incorrect partial fill calculations, and this again was found in parallel, right, by the team, and they fixed it, and we essentially made sure that the fix was correct, and and the fact that it also did not have the other implications, right? Maybe the same pattern was in multiple places. Maybe the team project, protocol team found it in one place and fixed it. So those are all the other things that the review still has to consider. Let's see. Okay, so this is an interesting point. So the swap functions would fail for property check, and I think let me just call the takeaway here, right? So, like David mentioned, there were a couple of routers, really different, files. There was this LSS VM router, which was the older one, and then they added a new one called the very fast router, and it wasn't entirely clear. In the audit scope, both these were listed, right? But only once we started doing the review and we started asking them questions, we realized that the LSS VM router, the older one, was planned to be deprecated, right? And all the new features were really being added only to the very fast router. And this is sort of verbatim from the protocol team. LSS VM router has been modified very little from the audit, right? So they did modify, but at some point, I think they figured that, let's not overload this router. Let's keep it and deprecate it over time, but let's write something, faster and better, right? So this was done. So we did spend some time trying to understand issues in the older router itself, like, with this issue. And then over time, we realized that, so this is actually meant to be deprecated. But for completeness sake, we still included that because it was part of the scope. So this one won't dive into it, but this is essentially similar to the one that Lucas mentioned earlier. So there were multiple functions that only supported the 721 NFTs. So the new support for 1155s were still missing. It just felt like maybe the protocol team wasn't completely, maybe they needed a couple more weeks or so before the audit, so that they could actually add all the support and test it out. So there were some of these, like the balance thing that Lucas mentioned, which would fail, the simplest of the test cases, right? And similarly, this one would, you didn't really need to analyze too much. It would fail for 1155s. Then, let's see, we have maybe 5 more minutes if we can take that. Let's pause here and see if there are any questions, because if not, we can use the remaining time to go into more issues. Are there any questions or other things that people have at this point? Okay. So let's sort of any other thing that you want to, David or Lucas, you want to touch upon in the ones and the issues discussed so far?
The one regarding royalty, wanted to comment that it is very interesting that there was a certain attack where you could like bypass the royalty payout.
This one, right?
Yes.
Is this the one? Yeah. Yeah.
So I thought that this one was really fun.
Correct. So this is, again, one of the key takeaways was just like how 1155 assets were not being considered along all paths in the logic, there were also these, this new concept of royalty, right? So they had older functions, right, which would send back the quote for a particular NFT when somebody's trying to sell for it. And they had a new version, which was, overloaded with the royalty support, right? So there was a new function that was added, but then there were multiple parts of the logic which used the older non-royalty, as in the ones that did not support the royalty, right? So that was clearly a deal breaker, because if somebody can trigger those flows, right, then royalties would not be accounted for, right, as expected. So multiple such things. Let's see, is there any takeaway here? So this was a very simple sort of issue that could be, actually observed without understanding what the expected behavior is, right? So in multiple places for optimization and other reasons, they would apply a trading fee that was 2 times this variable. But then there was one particular function where it was just trade fee, right? And there's obviously, in this case, there wasn't a comment or a documentation about why that is not 2 times like the other 2 places. So I think this is where not much of a discussion here. But we discussed this on some of the comments on the PRs. And we realized that, yes, so that was indeed a bug, right? So in that flow, it should have been 2 times. And then ultimately it ended up that that entire function was removed. So, for I think to fix some of the other issues that we discussed. So that was interesting. And that is maybe, sort of a pattern, like an anomaly pattern that is interesting to keep in mind during an audit is, even if you don't know what the invariant or a constraint is, if you see that there is a particular invariant that looks like an invariant along, some certain number of flows, and if that is not being done on some other, part of the logic, then either that is an exceptional part where it should not hold good in which case it is not like a protocol-wide invariant, or if it is a bug, then that particular flow is a bug, right? Because that invariant is missing. So there we don't need to know that it needs to be 2 times trade fee, as in this example, right? It was not, I don't believe it was documented anywhere. So that's sort of a good pattern or anti-pattern to keep in mind. Then
I wanted to, Rajeev, I wanted to comment something related with that, which is regarding the assumptions aspect. There was a very, very fun low severity finding, which was related to, it's number 68. It's related to legacy NFTs, right? So punks or other legacy non-standard NFTs, they are not compatible with this LSSVM because since they do not follow the standard, you can actually not use them. And so you're actually assuming that when you're working with NFTs here, you'll strictly get ERCs 121s and 1155. But if someone wanted to, use a CryptoPunk here, that would not work. So the mitigation, for example, was to add a wrapped versions to make them 721 like NFTs. So it also touches upon the assumptions part, but it's less, less heavy impact because which are the chances, right, of using a CryptoPunk? Like not everyone has one, right?
Right, and that was also one where we had to check with them, and they did clarify that they would not, they'd be okay with not supporting it, and there are other ways to deal with it, right?
Yes.
So let's go over a few more. I think we have maybe 10 more minutes. So for anyone who's interested and is still sticking around, we'll maybe go and look at some of the medium severity ones as well. So this one was, as it says in the title, right? Error return codes were ignored. And this is another very obvious pattern, right? Where a function returns an error, but the caller doesn't check. And in some of the cases, it's okay. Then, if that is the case, then we should question why is that function returning an error at all if it is not being checked at any of the call sites. But if it is being checked at some of the call sites and not in the other call sites, then it sort of becomes an interesting question. Is this an invariant, right? So in this case, it was, it was meant to be checked because otherwise it would be returning, the zeros and which would cause unexpected behavior. So as you can see, there are multiple functions, and the team actually, they covered it. They fixed all of those in this particular PR, right? And okay, so this is maybe a good example of an incomplete fix. So we did recommend them, in this case, right? So Gerard had mentioned all these, and then there was a particular PR that claimed to fix it, but then it looked like, okay, it's not completely fixed. And we go back and forth as interested, and then Gerard comments here that there are still a few left. And I believe, so you see this, add full error checking to standard settings. So this is sort of your fix review in progress, right? So they fixed it, or they think they fixed it, but then on checking something is not, so we go back. The last one I think is the one that Lucas already mentioned. Won't talk about that. Then let's look at how that.
That one, I believe it's interesting to get into the issue because there was a very fun conversation happening regarding, yes, exactly. If you go below, yes, it has been reverted by mistake. So Gerard noticed that, and the team said, "Oh yes, it was a misclick. I'm sorry. Just undo the revert, and then it works again." So that was anecdotic as well.
Yeah, I think that's a good point. All right, let me skip this. I don't think it has much, but a takeaway from this particular issue is sort of comes to your trust model, right? So like we said, settings is a particular actor in this protocol, and if you assume that it's a malicious contract, although they have this concept of whitelisting, right? It could be malicious, and in that case, it can do something and take over the pair, right? So let's see anything else here. Okay, not. So that is one interesting. So these are medium because there is an assumption that this particular contract could be malicious, right? I mean, there is that conditional aspect. So the likelihood is not as much, right? Which sort of reduces the severity to medium. Skip this. Let's skip this. Okay, let's talk a bit about this. So this is, I think, like a design bug. So like we said, there was a new router, the very fast router, which was where all the changes were being done. And in the older one, there were two recipients, right? So these are swap functions, and you're doing sells and buys at the same time. So in this particular case, the new router essentially, maybe for optimization of, I forget what reason they gave, there was a single recipient for receiving both ETH, ERC20s, right, and the NFTs. Whereas the older one had a separate recipient for tokens and a separate one for NFTs. So the claim here was that, it is error prone, because when a user has both sell orders and buy orders, then the tokens that are being sent for the sell orders and the NFTs that are being sent for the buy orders, both of them end up going to the same token recipient, right? And if this were sort of an integration thing where the front ends are integrating with V2, the ones that were working with V1 are now integrating with V2, they'll actually surprise the users who send this buy and sell order, because now both the NFTs and the tokens go to the same address. And in this case, it was more sort of error prone because the protocol was using transfer from as opposed to save transfer from. So in this case, NFTs could be sent to the user's contract that wasn't ready for 721s, right? But wasn't ERC 721 receiver and could get locked forever. So the recommendation was to sort of, and this was really in the data structure for the fast router compared to the older one. So the recommendation was to essentially add a separate NFT recipient in order similar to the older router. So this was solved. This was fixed. Let's see anything else. Yeah, so this one was essentially, Lucas mentioned the bonding curves, right? So you do have the bonding curves, but then the protocol, I think one of the concerns was for the LP to be able to change the price, the spot price and the delta for the bonding curves if the market is being, is very dynamic, right? If it is changing really quickly, where some NFTs, when the tokens, I guess when somebody creates a pool, right when the new tokens are being minted, new NFT project comes, or maybe when people are dumping on the NFTs. So they wanted, I think they mentioned this here. Yeah, so they wanted the protocol design to allow the owner to be able to change the spot price and the delta, right? Immediately, right? Without any delays or anything like that. So the users essentially could, if they did not use the max input and min output, sort of the slippage variance for NFTs, right? If they didn't use this or set this properly, then they could end up with very few NFTs or tokens. So that was the concern here. All right. I think there are a couple of, this exchange for zero tokens and the price decreases. This was again related to the same thing. But again, the onus was on the user to take care of themselves. Let's see. I think there are a couple of other interesting ones. So let's talk about a bit about the re-entrancy one, right? Like we mentioned earlier. So in this case, it was a cross contract reentrancy because every pair had its reentrancy modifier. But then what Gerard was at least able to hypothesize is that there could be a potential reentrancy under certain scenarios, right? Where the reason for that is because, from one pair you could actually re-enter the other pair, and both pairs have their modifiers, but they're two separate contracts of their own, right? So that their non-reentrant modifiers are different, so they really don't have a reentrancy protection, right? And this is another sort of interesting, humbling thing, right? That we acknowledge that we haven't found a realistic scenario to abuse this, right? And this is again because it's a time-bound effort. We couldn't come up with a scenario where this could be abused, but we still mentioned this because maybe the protocol team over time they figured out that hey, this is actually an issue and they fixed this. And in this case, we did suggest one of the recommendations was to put the reentrancy at a higher level, right, on a common location, so in the factory itself, so that the reentrancy guard would actually be effective across all the pairs that are created by the factory. So in this case, the protocol team actually did acknowledge that this could, maybe reentrancy is something that shouldn't be treated very lightly. So they actually did fix this in 2 different PRs. So I think, so this was one, there was quite a bit of discussion. And as you can see, right? So that was interesting. What else? Oh, this is interesting, I think. So this is interesting in the context of the recent, the Tornado Cash DAO attack that you may have seen, right? So this particular issue was essentially about contracts being considered as trustworthy, again, within the trust model, right? But it did not account for the fact that those critical contracts, assuming that the creator, the owner, is malicious, could redeploy it with a create to and self-destruct pattern, right? I mean, this was the most recent governance attack that we saw. So the suggestion was that, hey, these are actually being spun out of a factory. So why can't we check if indeed the factory, maintain essentially a mapping that of all the contracts that are being created by the factory and check that these contracts are indeed the ones that can be trusted because they were created by these factories, right? So in this case, as you can see, the team acknowledged, and for different reasons they wanted it to be more flexible and extensible, so they didn't fix it, but thought we would call this out because this is something that was exploited very recently. All right, I think there's maybe one other thing that is interesting. I think you're out of time. So this is actually Lucas, David. Do you guys want to take this? I feel like I've been talking forever.
Yeah, I can take this one if you want.
Sure.
So yeah, as the title indicates, a malicious front end could sneak intermediate ownership changes to perform actions that are not supposed to be done, right? So this was, if I'm not mistaken, a multi-kill function, right? Was it?
Yeah.
Yeah. Yeah, exactly. Yeah, I'm just reading it now. So yeah, then during the call, you could do whatever you wanted, basically, because if you change the ownership of the contract in the loop, then you could change something else on your favor and then change the ownership back before the loop ended. And right. That's where actually the check happened, right? So the contract misleadingly thought that the caller was the owner and nothing bad has happened, but you actually did it in the meantime. Such scenario would take some decent amount of gas, right? But yeah, it's possible, so better not risk it.
Yeah, and in this case, I mean, this is typically, again, it depends, right? I mean, we're talking about malicious front ends here, which are usually, well, by default out of scope because they can do many things that really the contracts, maybe they don't even interact with these contracts, right? Something totally else. But in this case, we did see a comment in the code. Where is that? Yeah, so prevent multi-call from malicious front-end sneaking in ownership change. So essentially, like Lucas said, there's a multi-call, and once it finishes executing all the functions, all the calls in it, there was this check that none of those functions actually change the owner, and the owner is really the person who called it, right? I mean, the message sender. So this triggered sort of one thought saying, you know what? Oh, so maybe if that is within the threat model, then what if it changes the owner and then changes it back, so that this check actually passes after the multi-call, but somewhere during the multi-call, one of those functions actually triggers something unexpected. So that was again, this is something we assumed, we mentioned some scenario, and then they said, hey, that won't happen. And in this case, I think, yeah, it was probably me. So we are discussing back and forth, and then they did add a particular fix, right? So they did prevent a certain call in the multi-call, so that they get a better threat model in place. So yeah, I think there are a whole bunch of low severity and informational ones. A lot of the informational ones sort of were more in the design space, with us recommending not something that is very code specific, but some maybe redesigns to the architecture, to the design. And we went back and forth with the issues, and some of them I think were fixed, and quite a few of them were acknowledged as well. So with that, I think.
Sorry.
Yeah. Sorry, you say something?
Yeah, I wanted just to comment that, for example, we had just a big issue regarding NatSpec. That some functions had like copy-pasted NatSpec from other very similar functions, but they had to, change maybe a parameter name or so on. Very minor things, as Rajeev commented, just the no impact on the code, but good practices mostly.
Right. And do you want to end with some of the key learnings, David? Sorry, Lucas. I forget.
So it's important to take a look on what we learn in this audit. And first of all, if you add new assets that are gonna be compatible, like this new standard of NFTs on the protocol, and take a look into, for example, the CryptoPunks, as Lucas said. And yeah, so take a look always on its type of asset, because there are really weirdo assets that can be found. Also, as you add new assets, you should add new flows that follow the same model as you were using before, but with a few different changes, and take a look on those changes, because if not, the impact is gonna be huge. Also, it's like the unanticipated threat model. You mean with that they didn't finish the fixes, I guess. Also, there are some important things about the parallel dev audit, like this kind of stay talking with the team, the people we are auditing. The communication is very important, and also the target diagrams that Gerard provided us were really useful at the moment of finding.
All right.
Last chance for questions.
So this was so much content. People will have to take a bit to kind of like swallow it and think about it nicely. And then when they will be dreaming, probably they will come up with some questions. You pretty much addressed everything with the last slide, but one question that I had, well, in fact, it's two questions, I would say, is that there is a lot going on, right? And you could consider Sudoswap to be a building block or some sort of like primitive in the space because of the way of how they create these AMMs interfacing between DeFi and NFTs. And I was wondering that what are the things that the researchers should think about immediately, right? Like security wise when they encounter these kinds of protocols. How do you wrap your mind around it?
Yeah, good. Go ahead.
Should we take each one point of view of it?
Yeah, go ahead.
I'd say that it code wise wasn't really big, but it was really complex because most contracts were intertwined, right? So in that sense, it was very important to have that. First of all, that diagram so you know what was happening. Big overview, exactly that one. It might be a tough pill to swallow because the diagram itself is complicated, and once you have that, you'll have to start with what I consider the basics, which is which actors have access to which things, which actors call what, and based on that, does it make sense? Do those access control settings make sense, right? Does it make sense that the AMM can call something else? Does it make sense that the user can call certain contracts and so on, right? Certain contracts that are supposed to be internal, right? Access control is something I would look first, at least from my perspective. It gives you a big image of what is going on and gives you certain hints of which things can be missing. At least that's the first thing I can think about.
Yeah, one thing that I can add is, again, very generic, very high level, right? What's the trust model? I mean, ultimately, all these issues boil down to what Lucas just mentioned, right? Who are the actors? What are the assets? Are they moving in the flows that are expected? And in this particular case, I think, let's see if we can do a slideshow. So there were a bunch of actors, right, who we really assumed that, there's certain whitelisting for the routers, so that was okay. And I think there were a bunch of issues where we pointed out that, this whitelisting may not be really effective, as in, what's the process of whitelisting, right? Is it based on the code, or is it because, the team that is implementing this new router, what is it based on, right? And if it is based on the code, then what sort of checks or should it have, or what should it not have for it to be whitelisted? I think those are sort of broader questions and not really relevant to this particular V2 of this protocol because it was still a permission router, but they were planning for this to be permissionless, right? All the design was essentially headed in that direction, right? And the other actors in this case were the royalty registries. So, if we do not have an understanding of how they work, and there are so many of them, right, they probably behave in different ways. So we had to sort of look them up as to, okay, what does this manifold do? What does, Nifty registry do? Foundation registry? What do they handle? The various admin functions for them. So all these assumptions were sort of baked into the code. But as a reviewer, when you look at it, there is, sort of real-time research and learning to do because, these things, over time, like Pablo mentioned, they may become sort of building blocks where all these things are vetted, there's libraries, and everybody understands it's all been, like Open Zeppelin ones, people know that, okay, these are audited, so you don't have to worry about them. But until then, just figuring out what they do, we essentially had to look up, okay, I had no clue what, Digital X was, right, at this point. So look them up and find their code base and, figure out, okay, what does this has admin role in them? how does it actually work, right? So all that is makes it tricky. And I don't know if he answered Pablo's question, but I think over time, there are some common sort of takeaways, like the ones we mentioned, right? Patterns. But otherwise, it really depends on what that NFT, either AMM or a lending protocol does in this case.
I would add to this that apart from access control, always take into account what are these assets, what are these assets gonna do, which are these assets, where they go, are they expected or not, who can call everything regarding assets at the end is where all the mess used to happen, apart from access control most of the times. So as this protocol uses a lot of types of assets, just go one by one and put into a list all what can happen in each of the ERCs, and just go and check all these, like a list, in my opinion.
Yeah, good one.
Right.
And that reminds me just one part of, I think it was Jocelyn from Trailer Bits. So this is always sort of a favorite question everyone has, right? That, hey, how do you approach? You have this protocol code base. Where do you start? Do you go from in to out to in? Do you just go libraries, or do you go? Do you look at the core and then to the periphery? I think Jocelyn, if I'm not wrong, was the one who said that he looks at asset outflow. Right? What are the assets in this protocol? Where do they go out of this protocol? And then he says, okay, this is where it goes out. So now who are the actors who can trigger anything that can make these assets go out? Because ultimately it is loss of funds that is the highest priority, right, for anyone. So that was an interesting approach or interesting framing.
Yes, thank you very much. Such a thoughtful and thorough response to that. And also, just by looking at the diagram, we know that that's a very small part. And as you mentioned, like the asset outflow would make you go much deeper into the rabbit hole. And you would have to spend 3 weeks just expanding that diagram to understand what else is happening. So, folks, we are so over time. Unless there is like a pressing question, we should be finishing this right here. So let's give folks 5 seconds to ask a question. Goes 3, 2, 1. Well, if there are no questions here, then thank you very much for the 3 of you for coming. This was an excellent presentation, extremely thorough.